Hi students, welcome to the virtual class of Design of AC Machine. This is Professor Gaurang Patel from Mahatma Gandhi Institute of Technical Education and Research Center, NAVSAR. Today we are going to learn regarding the design of AC machine, types of different induction machine, what are the main parts of induction machine, and what are the applications of three-phase induction machine in the industries. Okay, so in today's lecture there are the contents I will going to explain you one by one. First of all, we will start with the introduction. In introduction part we will see what is the induction motor and what is the working principle of induction motor. Then next we will see the parts of induction motor. There are different parts which consist in induction motor. There are different types of induction motors which is very useful in the industry. Then we will see what is the principle of operation of induction motor, that means how it will going to be functioned. Okay, then next, what is the synchronous speed and slip. The synchronous speed and slip are very important term for the three-phase induction motor. And then we will see one example related the three-phase induction motor. Okay, so first of all, in introduction I want to say that the three-phase induction motor are simple in construction. Okay, simple in construction, that means it is not required any commutator as in the case of DC motor. So no requirement of commutator, that means no requirement of brushes. So by means of that, it's rugged, less parts are there, so there is a low cost and easy to maintain. And one main advantage, that is they run at a constant speed from no load to the full load. Therefore these motors are frequently used in industry. Okay, so you can see, I will just, okay, so these are the three terms which I explained you. Three-phase induction motors are simple in construction, as I explained you. It is rugged, low cost and easy to maintain. Why it is low cost? Because it is having a less parts with compared to other motors. And the last one, the main advantage is it will run at constant speed from no load to the full load. Okay, so now next we will see in these things. You can see this picture. This picture is of very famous scientist Nikola Tesla. Okay, so the invention of induction motor permanently altered the course of human civilization. This 100-year of motor invented by a great scientist Nikola Tesla, the most common motor type even today. In fact, the 50% of global electric power consumption is due to the induction motor. Okay, and it's consists 90% of industrial motors are induction type. So you can see what are the major roles or how huge role induction motor are playing in industrial world. Okay, so in induction motor there are mainly two parts of induction motor. That's how the induction motor connected in industry for the several applications. Okay, so what I discussed, that is there are main two parts. There is one stator part and another one is the rotor part. This is the main two parts of the induction motor. Okay, so stator is basically three coil winding. Okay, it is basically a three coil winding. The stator is look like that. If you remove the rotor from the stator, and if you can see in your laboratory, the stator is look like that. Okay, so basically the stator has the 3 coil winding. You can see in the picture. Okay, the stator, this is the winding. You can see it is the 3 phase power input is given. So stator is basically 3 coil winding, and 3 phase AC power is given as an input to the stator. Okay, so winding passes through the slots. You can see in this construction there are different slots are given. Okay, so these are the slots. You can see when winding is passes through, these are the slots. We will see in another picture so you can understand it better. Okay, so this is the stator slots what I discussed you about. So winding is passes through the slots of the stator, which are made by staking. Okay, why it is made by staking? It is made by staking to reduce the eddy current losses. Now what is the staking? I will show you in the next slide. So it is called staking. When you can see the picture, that is this part you can consider as a staking. So different plates type construction will be there, and then it will be joined together, and the stator is made of different staking to reduce the eddy current losses. Okay, now when a 3-phase current passes through the winding, something very interesting happens. Okay, when a 3-phase current, you can see this is the 3-phase current. We can consider 1, 2 and 3-phase current passes through the winding. The rotating magnetic field is generated. This is the rotating magnetic field. You can see the N and S. Okay, rotating magnetic field is generated when 3-phase current is passing through it. Okay, so okay, up till now we will talking about the stator and about the stator winding. Now we will see the rotor of the 3-phase induction motor. Okay, so rotor, it's composed of punch lamination with rotor slots for rotor winding. Okay, so from rotor we can divide it our 3-phase induction motor mainly in 2 types. The first one, that is the squirrel cage induction motor, and the next, that is the conventional 3-phase induction motor. Okay, here is the picture of squirrel cage induction motor. You can see in that picture, for squirrel cage rotor is it consists of copper bars. Okay, so these are the copper bars which I am talking about. It consists of copper bars which is slightly longer than the rotor. These copper bars are pushed into the slots, and you can see the ends are welded to copper so that all bars are short circuited. You can see that is the end of that copper bars which is welded with the copper rings, and it all copper bars are short circuited. Okay, the next one, that is the wound rotor. Next type of motor, that is the wound rotor. A wound rotor has a 3-phase winding similar to the stator winding. You can see in the slide there is a circuit diagram of three-phase induction motor is given. This is the stator part and this is the rotor part. So a three-phase winding similar to the stator winding. So rotor has a similar pattern of winding like the stator winding. Okay, so the rotor terminals are connected to the three slip rings which turn with the rotor. These are the three slip rings with the rotor winding is connected. You can see, I will just remove all those things. So three slip rings that is connected with the three windings, you can see it. Okay, so the slip allow external resistors to be connected in series with the winding. These are the external resistors which are allowed to connect it with the series winding. You can see these things in this picture as well, so you can understand it better. Okay, what is the role of external resistor? The external resistors are mainly used during the startup. Okay, when we start the induction motor, we will include this external resistor, or we can say we can insert them during the starting of the three-phase induction motor. And then in under normal running condition, the windings are short circuited externally. Okay, in normal running condition, this winding is short circuited externally. So that's how this wound rotor is work, and this is the circuit diagram you can see in this picture, and how it is work you can understand through this connection of this diagram. Okay, now we will see how the induction motor is operate and the operating principle of induction motor. Okay, so now you can see these are the terms what I already explained to you, how those wound rotor is working. Okay, we will switch over to the operating principle of induction motor. Okay, so in induction motor, the operation of a three-phase induction motor is based upon the application of Faraday's law and the Lorentz force on a conductor. Okay, here first of all we will just see the steps of operating principles, then we will understand it better in next slides. Okay, so the operation of three-phase induction motor is based upon the application of Faraday's law and the Lorentz force on a conductor. Okay, in that a permanent magnet moves at speed v so that its magnetic field sweeps the conductors. Okay, so the permanent magnet moves at speed v, and with that magnetic field sweeps the conductors. And this point tells us that a permanent magnet moves at speed v, its magnetic field sweeps the conductor. Okay, okay, then next we will see these are the steps which we are going to consider in the operating principle of the induction motor. So the first step, you can see this is the first step, that is a voltage E is equal to BLV. Okay, E is equal to BLV. A voltage is induced in each conductor while it's being curved by the flux, that is the Faraday's law. And the next point is says that the induced voltage produces current which circulate in a loop around the conductors. Okay, so whatever the voltage is induces, it is produces the current in the rotor and stator, and which circulate in a loop around the conductors. Okay, the third step is says that since the current carrying conductor lie in a magnetic field, they experience a mechanical force that's also known as the Lorentz force. And Fourth one, that is the force always acts in a direction to drag the conductor along with the magnetic field. Okay, so these are the steps of operating principle of induction motor. Okay, these 4 steps we will understand one by one how magnetic field is generated and how the three-phase induction motor is going to be rotated. Okay, I just repeat those 4 steps once again for your better understand. The first step says that a voltage is induced in each conductor while it's being curved by the flux. Okay, so as we know about the machines, whenever the flux cut by the conductor, there is an EMF is induced. Okay, so whenever the flux is cut by the conductor, EMF, that means voltage is induced. So whenever voltage is induced in the conductor, it will produces the current. Okay, and whenever we insert the current carrying conductors lie in a magnetic field, they experience a mechanical force. Okay, so here the current carrying conductor is our rotor. Okay, so it will experience the force, and this force is in the direction of rotating magnetic field. So whatever the direction of rotating magnetic field, our rotor will catch that direction of rotating magnetic field and it will rotate it. Okay, once again I will say you that we will understand it one by one with upcoming PPTs or upcoming pictures. Okay, so you will learn it very deeply because the principle of operation of three-phase induction is very important to understand. Once you understand what is the operation, then you can able to understand each and every part of the induction motor and design of each and every part of induction motor. To understand how the rotating magnetic field generated, we simplified the stator winding. Here, 3 coils are connected 120 degree apart. Okay, we can see that there is a coil number 1. If we consider, there is a coil number 2 and there is a coil number 3. So the 3 coils are connected 120 degree apart. This wire we can consider as a current carrying wire. Okay, a wire carrying current produces magnetic field around it. You can see a wire carrying current produces magnetic field around it. Now when a three-phase power supply to this special arrangement given, the magnetic field produced to be assumed at a particular instant. So we can see that whenever the current carrying conductor, there is a very basic phenomenon of induction motor. So whenever the current carrying conductor is placed, there is a magnetic field produced around it. Okay, now with variation in AC currents, magnetic field taking different orientations. So now we know that with variation in AC currents, magnetic field taking different orientation. If you compare the 3 instances, here if you compare these 3 instances, so you are able to know that it is like magnetic field of uniform strength rotating. It is like a magnetic field that is uniform strength rotating at different instances. Rotational speed of magnetic field was known as the synchronous speed. Whatever the rotational speed you can see over here, which is known as the synchronous speed. The synchronous speed phenomenon we will understand over here, you can see at the different instances the three-phase current will going to be produced due to this magnetic field. This is the first phase, you can see, that is the single phase, second phase, and that is the third phase. If we consider, it is produces when this loop is rotated. Okay, so as soon as you putting a closed conductor inside it, according to the Faraday's law, a closed conductor, that means that is the closed conductor. Okay, this is the closed conductor you consider. What I want to say that as soon as you putting a closed conductor inside it, according to the Faraday's law, because of magnetic field is varying, and EMF will be induced in the loop. Okay, so the EMF will be induced in that loop. Okay, so you, whenever the EMF is induced in that loop, the current will be induced inside that conductor, or you can say the EMF will produce a current in the loop. Thus the situation has become like a current carrying loop inside the situated in a magnetic field. According to the Lorentz law, an electromagnetic force will be produced on the loop, and the loop was start to rotate. So the Lorentz law, what Lorentz law says that electromagnetic force will be produced. Okay, so you can see here there is a electromagnetic force is produced. So whenever the electromagnetic force is produced and current carrying loop inside that, that loop also experiences that force, and due to that force the loop was start to rotate. Okay, the same phenomenon occurred in induction motor as well. Here, instead of simple loop, squirrel cage induction rotor is used. So same phenomenon or same principle will be applied to that induction motor. We can see that if this current carrying loop we placed inside that magnetic field, it experiences the force according to the Lenz's law. So instead of this loop, now we'll place the rotor inside the motor. Okay, so how it will work, we will see it. Okay, so you can see there is a squirrel cage rotor. You can see in the picture there is a squirrel cage rotor. This is the squirrel cage rotor which is having the different bars. Okay, so the three-phase AC current passing through the stator produces the rotating magnetic field. Okay, so current will be inside the bars and current will be induced in the bars of the squirrel cage, which shorted by end rings. So the rotor will start to rotate. That's why motor is called an induction motor. Okay, so why this motor is known as induction motor? Because it is induced, electricity will be induced due to the induction, not by any further connection. That's why it is known as the induction motor. Okay, so I hope you know how the electricity will generate the magnetic field and how the force is affect to the rotor to force the rotate. Okay, you can understand better with this picture as well. you can see we consider it is a rotor, and this is the winding of stator. So due to that stator winding, this magnetic field is generated. Okay, and this magnetic field is coincide with this rotor bars. Those are the rotor bars. So whenever this rotor bar is experience a force due to the magnetic field, it will be rotate in the direction of that magnetic field according to the Lenz's law. Okay, these are the force. You can see these are the force that forces this rotor to move into the direction of the magnetic field. So now you able to understand why the rotor is rotated due to that generated magnetic field. Now we consider a case where rotor speed is same as synchronous speed. Okay, here you can see the rotor speed is same as the synchronous speed. This is the rotor speed and this is the synchronous speed. Due to the fact both are rotating at same speed, magnetic field never cut the loop. So there was no induced EMF and current. Okay, I will explain you once again. If we consider there is a rotor speed and the synchronous speed is same, there will be no magnetic field is cutting the loop, so there is no induced EMF. So if there is no induced EMF, there is no current will be induced into the rotor bar. Okay, this translates zero force on the rotor. Okay, because no induced EMF, no current, so there is no force. So that will be the zero force on the rotor bar. So rotor will gradually slow down. As it is slow down, magnetic field cut the loop. Okay, it is very important to understand. Whenever it is slow down, the magnetic field cut the loop and induced current, so force will rise again. Then rotor will then speed up. Okay, now we consider that rotor speed is slightly less than the synchronous speed. Over here you can see this is the rotor speed is slightly less than the synchronous speed. So the difference between synchronous speed and rotor speed known as slip. Generally slip value is 2 to 6%. So the difference between the rotor speed, that is we consider as a rotor speed, and that is the synchronous speed. So the difference will give you the slip, and we will consider the value of slip between 2 to 6%. Okay, now we will see some of the advantages of induction motor. As we know, induction motor do not require permanent magnet. Okay, it will not require permanent magnet. There is no requirement of brushes. There is no requirement of commutator rings. There is no requirement of position sensors like other motors required. If we consider the DC motor, we need a commutator over here. Okay, if we consider the BLDC motor, we need a sensor at the 120 degree apart to sense the position of the rotor. So there is no requirement of additional equipments in the induction motor. That's why it is very popular. Okay, and one more advantage, that is it is simple and rugged in construction, as well as it is easy to control its speed from no load to full load. Okay, so induction motor are also self-started. Most important part, that induction motor speed can be controlled easily by controlling its input frequency. Okay, and finally we will see one example regarding the induction motor. In example, it asks that a three-phase induction motor having a 6 poles 50 hertz is supplied by a three-phase source. Okay, the rotor is rotating at 800 rpm, so we have to calculate the slip and the rotor frequency. So for calculate the slip and the rotor current frequency, we have two equations. I already provide you to the solution of this example as well. So what we require to find the slip, okay, and the, you can see what we require, the slip and the rotor current frequency. Two things we have to find. So first of all, we have to apply the equation for that synchronous speed. So equation of synchronous speed, that is 120 f by p. So 50 hertz frequency is given and pole 6 pole is given in the data. So here synchronous speed we found 1000 rpm. So from that, if we apply the equation of slip, that is the synchronous speed minus rotor speed divided by the synchronous speed. If you put the data whatever we found, you will get the answer 0.2. so that is the value of slip what we find out over here. Okay, so that's how the first term we are going to find out there. The second term, that is the rotor frequency, the equation of the rotor frequency, that is slip into the f of s. Okay, so for the second term, so over here fs stands for the stator frequency. We already found the value of slip, that is 0.2 into 50. So the answer of second term, that is the rotor frequency, is 10 hertz. Okay, you can solve those kind of examples will provide you a better idea of that particular induction motor. Okay, so I hope you understand the basic principle of three-phase induction motor as well as the different types of induction motor, and the main or very important part, that is the principle and the operation of three-phase induction motor. Thank you. So finally we discuss one question which was asked in GTU in May 2017. The question was, give the difference between squirrel cage and slip ring induction motor. Okay, so we are dividing two parts over here. First one, that is for the slip ring induction motor, and the next one is for the squirrel cage induction motor. So in slip ring induction motor, there is a first point is discussed, that is construction is complicated due to presence of slip ring and brushes. Okay, and in squirrel cage induction motor, construction is very simple. The next point is the rotor winding is similar to the stator winding in case of slip ring induction motor, and in squirrel cage induction motor, the rotor consists of rotor bars which permanently sorted with the help of end rings. Now next is, we can easily add rotor resistance by using slip ring and brushes, and in case of squirrel cage induction motor, since the rotor bars are permanently shorted, it's not possible to add external resistance. Okay, so the next point we can see, that is in case of slip ring induction motor over here, for your better understanding, just a moment, I will show you. The first one is the slip ring induction motor and next one is the squirrel cage induction motor. Okay, so This is for the slip ring induction motor, and this will be considered as squirrel cage induction motor, so you will not get any confusion regarding it. Okay, so in first case, in slip ring induction motor in this slide, that is due to the presence of external resistance, high starting torque can be obtained, and in case of squirrel cage induction motor, starting torque is low and cannot be improved. Okay, the next one, that is slip ring and brushes are present, and in case of squirrel cage induction motor, slip ring and brushes are absent. Okay, frequent maintenance is required due to presence of brushes. Okay, and in squirrel cage induction motor there is no brushes, so there is less maintenance is required. Okay, in squirrel slip ring induction motor, the construction is complicated, and the presence of brushes and slip ring makes the motor more costly. It is obvious that more parts included, so the construction and the maintenance are high in case of slip ring induction motor. In other side, in squirrel cage induction motor, the construction is simple and robust, and it is cheap as compared to slip ring induction motor. Okay, some more point is still required to discuss. In over here, for slip ring induction motor, just remember this one for the slip ring induction motor, and this one for the squirrel cage induction motor. Okay, so for slip ring induction motor, this motor is rarely used. Okay, because we show that in previous points there are so many drawbacks with compared to the squirrel cage induction motor, so that's why this motor is rarely used. Only 10% industry use slip ring induction motor. Okay, and in squirrel cage induction motor, due to its simple construction and low cost, the squirrel cage induction motor is widely used. Okay, rotor copper losses are high and hence less efficiency. So in squirrel cage induction motor, less rotor copper losses are there, and so the efficiency is higher. This point says that speed control by rotor resistance method is possible. In case of squirrel cage induction motor, speed control by rotor resistance method is not possible. Okay, we can consider it is an advantage in case of squirrel cage induction motor, and this is the disadvantage for the squirrel cage induction motor. Okay, and the last one, that is slip ring induction motor is used where high starting torque. Okay, this point is given on the basis of application for both of the motors. Okay, so in squirrel cage induction motor, when the high starting torque is required, we are going to use slip ring induction motor. For example, in hoists, cranes, elevator, where high starting torque is required, or in squirrel cage induction motor, that is applications are lathe, drilling machine, fan, blower, printing machines, etc. Okay, so these are the points that you can consider if this type of question asked in GTU examination. I hope you understand this topic very well. If you have any query regarding these topics, please contact me. Okay, thank you.